Hello friends, we are going to learn Science 1 SSC Board, Maharashtra Board, first chapter, Gravitation. As all we know, gravitation, the phenomena is discovered by the great scientist Sir Isaac Newton. So what is meant by gravitation? Gravitational force, a force which is exerted by Earth on any object on the surface of the Earth is called as a gravitation force. Now circular motion. In circular motion, a particle revolves, a motion of the particles revolves in a circumference of the circle or along the circumference of the circle. This motion is called as circular motion. For example, the motion of fan, the motion of electrons along the nucleus of any element, it is called as a circular motion. These are the examples of the circular motion. Now come to the centripetal force. What is meant by centripetal force? Centripetal force, the important definition of this chapter, centripetal force. A force which binds the particle into circular motion is called centripetal force, which is called as a centripetal force. A force which binds the particle. Let us consider a string. We revolve a particle with the help of the string. Then this force means our wrist force, our muscular force is acting as a centripetal force. Centripetal force means the force which binds the particle into the circumference or into the circular motion is called as centripetal force. And its direction is outside to the circle, and its value is F equals to, it is given by 1 by 2 mv square, where m is the mass of the object and v is the velocity of that particle or velocity of that object which is revolving around the another object. So m is the mass, this is the centripetal. Another is a centrifugal force, but it is not in your syllabus. For your kind information, I will explain the definition. Centrifugal force is an imaginary force. The centripetal force is a real force. Centrifugal force is a pseudo force. It is an imaginary force. Centrifugal force is a force which acts along the tangent, or it is a tangential force to the centripetal force. So it is a tangential, means you can say that suppose this is a circle. Now the force, this is the centripetal force which is working outside the circle. Now here the tangential, which is tangential perpendicular to the centripetal force, it is called as a centrifugal force. Now next important is Keplers Laws. Kepler explained the laws of planetary motion. All the planets revolves in a circular motion along the Earth. Correct? But Kepler correct this statement. The motion is not in circular, it is in elliptical. So it explains about three laws, means Kepler's laws. Kepler's laws. Kepler states three laws. The first law, Kepler's first law. It is also called as another name, Kepler's first law. It is also called It is also called as an orbital law. Another name is orbital law or orbit law. Okay. Now, first law, Kepler's first law. This law states that every planet rotates or revolves in a elliptical path along or around the sun, where sun is one of the foci. Where sun is the one of the foci. Now let us consider, means this law explains that every planet revolves around the sun in an elliptical path. Let us consider the elliptical path. This is the elliptical path. Now let us consider these are the planets. Now every ellipse has two foci. Let us consider the first foci is the sun. This explains that. This law states that. So sun is the one of foci and these are the planet. So this is the P1, P2, P3 and this is the sun and this is their motion. Means the motion of the planet around the sun is, or the path is elliptical path and the sun is one of the foci. This is the first law, Kepler's first law. Now come to the second, Kepler's second law. It has another name, law of equal areas. Another name is law of equal areas. This law states that planet revolves equal distance, or a planet swept. You can write this, planet swept equal areas or equal distance in equal time interval. So let me explain. This is the elliptical path. Now this is the sun. Suppose planet is traveling distance from this point to this point. This is the distance S1 or area is S1 and the time is T1. Let us consider another. The planet swept the distance from this point to this point and this area is S2 and this time is T2. If what it explains, if time T1 equals to time T2, then areas or distances S1 equals to S2. This is the second law of Kepler, or it is also known as law of equal areas. Now come to third law, Kepler's third law. It is also called as law of period. Kepler's third law. It is also called as a periodic law or law of period. So now it says that Kepler's third law, the time period, the square of time period of planet, the square of time period of the planet is directly proportional is directly proportional to the cube of distance between the planet and sun. So this law states that square time. Let us consider diagram will help you. This is the sun and this is the planet. Now the time period means, let us consider t. The square of time period means t square is directly proportional to the distance. Let us consider distance between sun and the planet is here r. So r cube. Now the distance is, now let us consider this distance is a very small distance, this distance is a big distance as compared to this. Means the distance is always changing. The distance between the planet and the sun always changes. Means we can write in this way. T1 square is directly proportional to R1 cube. T2 square is directly proportional to R2 cube. So we can write, ultimately we can write in this way. T1 square upon T2 square equals to R1 cube upon R2 cube. This is the direct proportion we can write. So these are the three laws of the Kepler. So first law, very important law, first law is law. It is also called as a law of orbit or orbital law. Every planet revolves in an elliptical path around the sun, where the sun is the one of the first time. And the second law, it is also called as a law of equal areas, means the planet sweeps equal distance in a equal time interval. And the third law, very most important law, it is called also period law. Means what is this law? This law states that the square of the time period of the planet is directly proportional to the distance between the cube of the distance between the planet and the sun. These are the laws of Kepler. Now come to the next point. It is a very important in every exam. This question is asked by the examiner, and this is very important law. In 12th standard also this concept is there for 12th science. In physics, Newton's law of gravitation or universal law of gravitation. It is also called as, in your book it is mentioned that universal law of gravitation, Newton's law of gravitation. Next point is very important. Make a star to this point, Newton's law of gravitation. Or in your book it is mentioned as a universal law of gravitation. Very simple. This law states that Newton's law of gravitation, it states that every object or every body is attracted by another body with a force some force which is directly proportional to, for what? Directly proportional to product of their masses and inversely proportional to distance between them. Let us see. It states that every object is attracted by another object with a force which is, this force is directly proportional to the product of their masses and inversely proportional to the square of distance between them. The square of the distance between the two particles. Let us consider there are two particles. We will explain this law in the form of formula. Let us consider this is a object number 1. So this is I write A. The another object is B. The mass of the A object is m1. The mass of the another object B object is m2. The distance between A and B is r distance. Now a force, what is the definition? Force is directly proportional to the product of their masses, means m1 into m2. The force is directly proportional to the product of their masses, and the force is inversely proportional to the square of the distance. Distance is r. Little square means r square. Means we can write that F is directly proportional to m1 into m2 upon r square. Now let us consider F equals to G into m1 into m2 upon r square. This proportion I equal with taking G is a constant. G is called as a gravitational constant. It is called as a gravitational constant. It is also called as a gravitational constant. So my friends, what is the Newton's law of gravitation or universal law of gravitation? Yes, it states that every object or every body on the Earth's surface is attracted by another body or another object with a force, and this force is directly proportional to the product of their masses. We have taken the masses m1 and m2. It is directly proportional. F is directly proportional to m1 into m2 and inversely proportional to the square of the distance between them. So distance is taken r, so which is F is inversely proportional to the r square. So we have taken in this way F equals to m1 into m2 upon r square. F equals to G into m1 into m2 upon r square, where G is a gravitational constant. So this is the Newton's law of gravitation or universal law of gravitation. It is a very important topic in this chapter. So write down the statements and the formula for that. It will help you. Now come to next point. Now, next point is relation between capital G and small g. So I will explain. Relation between capital G and small g. So already I told you the capital G, the big G or capital G is the gravitational constant. It is a constant value, and this constant value is provided by board in the board examination. G is a gravitational acceleration. It is a gravitational acceleration, the force exerted by the earth, and in that force the acceleration is there. This acceleration is a small g. This value we consider, it is a considered value 9.8 meter per second square. It is a considered value. Now let us explain the relation between G and G. So let us consider capital M is the mass of the earth, and the M1, a small particle or small object which is present on the surface of the earth. The mass of the small object, mass of small object, the small m, small object. Capital M is the mass of the earth, and small m is the mass of the object which is present on the earth. Now, the force between this object, the force between this object and the earth, what is the formula? Yes, gravitational constant. So M1 M1 is here, capital M. M2 into M2. M2 means the second object. Here is a small m. And the distance between that object, let us consider this is the earth and here is the object. Means the distance between earth and object, let us consider the radius. Radius of the earth, it is a capital R. Radius of the earth is a capital R. Now, what is F? F means, force means the formula mass into acceleration. F equals to m into a. But here gravitational acceleration is a g. Instead of a, it comes F equals to m into g. So put this value in this equation. So what will? So m g equals to g capital M small m upon r. Now this small m will get cancelled. So g equals to gm upon r. Or capital G. This r will that side, gr upon m. So this is the relation between small g and capital G. Means gravitational constant and gravitational acceleration. So next part is variation of the g, small g, variation. Suppose this object is at a height of h, second is on the earth surface, and this second at the depth d. We will explain. So next is variation of small g. You can take these screenshots for your notes also, or I will provide the notes in the subscription link. Okay. Now, variation of G. First, let us consider the object. The object is on the earth surface. On the earth surface. Let us consider this is the earth, and the object is on the earth surface. Means the relation is, we have seen in last beat, it is a relation is G equals to capital G capital M upon R square. G is the gravitational acceleration, G is the gravitational constant, R is the radius of the earth, M is the mass of the earth. Now second, let us consider object is at height h. How much?